Hi, today we are going to discuss about a parametric equation. For first question, an object moves in a straight line and at a constant speed from the point 2 to 4, 2 to negative 4 when t equal to 0 to the point of 12, 24 at 5 seconds later. For first one, to create the straight line motion, first we need to create the equation for the line, which is y equal to mx plus c. For m is the gradient of the line, so we would want to know what is the gradient of the line. We will have the m equal to y. For the point given, we will need to use the point given, the y2 minus y1 and x2 minus x1, which is 24 minus 2 divided by 12 minus negative 4, and we obtain the gradient of the line is 2.8. Now we substitute the gradient into the equation and use the point 12 and 24 and put in the line, and we have get the y-intercept, which is negative 9.4, 9.6. So we have find the equation of the line, which is y equal to 2.x minus 9.6. To know the point, move from 0 to 5 seconds, to find the parametric equation, we need to find the speed of moving. So to calculate the speed, we need to use the distance divided by time, which is 10 divided by 5, so we obtain 2. And we have this, and the object starting point is at the x equal to 2 and y equal to negative 4. So we using the x, so the speed times the time times the t plus the x initial point, x naught is the initial of x. So we have find the parametric equation, which is 2t plus 2, and at the y is 5.6t minus 4. To prove this one is the parametric equation of this object. So we substitute. When the time is equal to 0, we get the point 2 and the negative 4, and we have put in again the time. When the time is 5 seconds, we have obtained the point at 12 and 24, which prove our parametric equation is 2x plus 2 and 5.6x minus 4. Okay, now look at the graph. It's a straight line motion. From the starting 0, let's drag up. This is the starting point at 2f and negative 4. When you drag it down, it's moved in a straight line. So now I'm going to give you another example of the straight line motion, which is x equal to 2t plus 5 and y equal to 3t. As you see, when starting at 0, the point is at 5 and the x is equal to 5 and y equal to 0. When you drag it down, move until 5, it moves in a straight line. After the 10 seconds, it will reach 25, the point x 25 and y equal to 30. This is the straight line motion. Okay, now I'm going to talk about the circular motion, which is question 2. An object is initially at 7 and 2 and takes 120 seconds to complete a circular motion of radius 4 about a center point of 3 and 2. To create the circular motion, we need to have the radius, the center point. We need to know the speed also. And the parametric equation for a circular motion, which is a cos b plus c and a sin b plus c. What is a? A is actually the radius of the circle, and b, which is the speed, c is the center point of the circle. To get the parametric equation of circular motion, we initially start at 7, 2. As you can see, I drag up. When it start at the initial point is 7, 2, which is here. When the time increase until 180, it actually is form a circle already. So we have know the speed is 120. So it's actually is 3t, which will actually form 3 circle. Let's see. At 120, we actually have a circle which have the starting point from the 7 and 2. And we drag it down to 240. It actually have another circle again. And until 360, it's actually there is a 3 circle inside. So we can have a parametric equation, which is the radius is 4 for cos 3t, which is the speed, because it takes 120 seconds to complete a circular motion, plus 3, which it start at the center point 3 and the 2. This is the x. Its starting point is at 3. And the y is 2, so the y is plus 2. Let's see more example down here. When the xt equal to cos t and the yt equals to a, which is actually an oscillatory motion, which is at the point which oscillate at the point y equal to a. It actually goes from back from 1 at here it reached negative 0.7. When it goes to the 360, it actually go back to the position, same position. The next one, which is also an example of wave time motion, which is x equal to cos t and yt equals to phi t plus 1. So let's see. It's starting at the 1 and 1. When we goes to the 180 seconds, it actually form a wave. For circular motion, we know that x squared plus y squared equal to r squared. So in circular motion, we will have the sine squared plus cos squared equal to t equal to 1. Let's see this example. For the first one, we have the starting point at, we have the radius is, in this example, the circle actually is centered at the 0 and 0, which you can see, and the radius is 1. So the next example, when x is equal to 2 sine t and cos equal to 2 cos t, and for the example before, we have stated a sine t, which a is control the height of the circle. So it's the 2 sine t is actually the radius of the circle, which makes it different from the example, from this example and this example. You can see it's at the 2 and this one is at the 1, which both graph is centered at the 0 and 0. And the next one, we have 2 sine 3t and 2 cos 3t, which actually the 3t is the speed of the motion. When the t reach 120 seconds, it actually there's a circle form already. When we reach 240, there's another circle complete, circular motion complete. When we reach 360, there's a 3 circle motion. Let's see another example for xt equal to 2 cos t minus 1 and yt equals to 2 sine t plus 1.